Hello there, welcome to a new video for Algebra 1. This is a part of a new unit on writing linear equations. This is lesson 1, where we're going to introduce the idea of writing linear equations. You may be thinking, writing? I don't want to do writing in math class. We're not going to be writing like sentences or anything like that. We're just going to be writing equations. So hopefully that seems at least a little better to you. I don't know. If you would like to download a free notes page and follow along with the notes that I'm doing here, you can click the link in the description, or maybe it's floating above my head right now, and go and get a free notes page as well as a free practice page to go with this lesson. Let's get started. Remember some things about linear equations. So there are two main ways that we can describe a line so that we would know that we were talking about the same line. One is by naming two of the points that are on the line. There's a theorem in geometry that any 2 points can form a distinct line, basically. So we maybe can pick a multitude of points, right, to describe a line, because a line is made up of lots of points. But if you wanted to convey to me a certain line, you could pick two of the points, tell them to me. I could draw those same 2 points, and I'd have the same line. And second, by naming a point on the line and the slope of the line. So today we're going to explore the idea that we can write something in slope-intercept form by figuring out what the slope and the y-intercept are. That's what slope-intercept form is, a combination of slope and y-intercept. So it's actually going to start off pretty easy. You're going to see in this unit and in this lesson a little bit, but overall in the unit, it's going to start off easy and it's going to get more complex as we go, and that tends to be how math works. But then whenever we start a new thing, it will end up being a little bit easier at the beginning and then get harder, and so on and so forth. So just keep that in mind if you are like, wow, this is super easy. We will make it harder. Don't worry, we'll get there. Example 1. Write the slope-intercept form of the equation of a line that has a slope of 1/2 and a y-intercept of 3. So slope-intercept form is y equals mx plus b. They've told us that the slope is 1/2. Slope is we use m to represent slope. The y-intercept is 3, so it's telling us that b is 3. So if we want to write the slope-intercept form of a line that meets these qualifications, we're going to replace the m and the b with 1/2 and 3, but we'll leave the y and x and y as x. So this gives us y equals 1/2 x plus 3, and that's it. That's the line that we can write. It's the equation of a line that we can write that fits what they gave us. There's only one line that fits this criteria. There are a couple different ways we can write it. We have other forms besides slope-intercept form, but it asks for slope-intercept form, so this is the only way to do that, is to write it that way. And it was super easy peasy, so that's helpful too. This example is pretty similar, so if you wanted to try it ahead of me, you can pause the video, start it back up whenever you're ready. All right, write the slope-intercept form of the equation of a line that has a slope of -2 and a y-intercept of 0. So again, they're telling us the slope is -2, so m is -2. The y-intercept is 0, so b is 0. So we plug this into y equals mx plus b, and that gives us y equals -2x plus 0, or even better, we could write that without the plus 0 and just have y equals -2x. And that'd be our answer. And that's it. Now, let's make it just a little bit harder. What if instead of giving us it like just explicitly stated, what if instead they give us a graph? How does that change things? We still need the slope and the y-intercept. Can we get those things from a graph? And if so, how do we get those things from a graph, right? So let's think about slope. Slope is the rise over run. So pick two of these points and count out the rise over the run. So it doesn't matter which 2 points you pick. It doesn't even matter which direction you go. But it does kind of matter a combination of those two. So like if I start at this point up here, I could rise 4 down. So that's rising a -4, and run 3 to the right, which is a positive direction. Or if you started from the middle, you could go up 4 and left 3, both of those give us -4/3. It's just that one of them gives us a negative on the top, one gives us a negative on the bottom, but one negative overall gives us a negative. So our slope here is -4/3. Our y-intercept is, where is this going through the y-axis, which is right here at a +1. So we just put this all together. Y equals -4/3 x plus 1. And that's our answer. Not too bad, right? Just have to basically do some counting. So again, you can pause the video and try this on your own ahead of me if you'd like to. Start up the video when you're ready. Let's see. The slope, which is our rise over our run, is going to be up 2/1. So 2/1, which would simplify just to be 2. You can write it as 2/1 if you want to, but writing it as 2 is simpler, so we like that better. And then the y-intercept right here is -5. My dot kind of covers up the negative, so make sure you pay attention if that happens, that it is a -5 because it's below the x-axis. So this would be y equals 2x minus 5. Let's make this a little bit trickier by putting some words in. So, mathematical modeling. One of our goals as mathematicians or scientists is to use equations to represent real-life situations, and we call this mathematical modeling. So if you think about what a model is in other places, like a model could be a model airplane, so it's a representation, like a smaller representation of something that exists. Or if you think about modeling clay, you can shape into something. You could have a role model, which is an example to you. You could have a model that is in like magazines and things like that, and it's showing something to you, right? Like fashion or something. So all of these things basically are encompassing this idea of modeling being having a representation that's different than what it actually is, right? I guess maybe not all of them are like that, but that's kind of the idea. Like a model airplane, it's not an actual airplane, it's a representation of it. This kind of works as our math definition. We have a mathematical model. We are using math to represent a situation in the real world. And linear equations in particular, which is what we've been talking about so far in Algebra 1, is going to model a certain type of situation super well. It's a situation where we have some sort of a starting amount and then a constant change over time. Even if the starting amount is 0 and we have a constant change over time, constant meaning it's the same change over time instead of it being varied change. We have lots of things that are going to work for this, that we can figure out the starting amount and the change over time, we can write an equation. So it's going to be kind of like what we did before, but also a little bit different, because now we will be given a situation and we'll have to figure out, okay, which of these is the slope, which of these is the y-intercept. So you want to save up money to buy the next big thing. I don't want to put any names to it because who knows what the next big thing is whenever you're watching this. When I made it, it could be the PS5 or the newest Xbox, or I don't actually know what iPhone we're on, if I'm being honest with you. But you're saving up to buy the next big thing. Let's say you start with $100 and figure out you can save $10 a month. Write a linear equation to represent this situation. So we've got only 2 numbers here. We've got to think which of these is our starting number and which one is our change over time. Well, our starting amount is 100 because that's how much we've said we have initially. And then our change over time is that we're going to gain $10 a month. Which of these is our y-intercept and which of these is our slope? That's definitely something I should have written on this slide. Our starting amount is our y-intercept because our y-intercept happens at an x value of 0. So at 0 for x, we start with some amount at y. That's our y-intercept. And our change over time is going to be our slope. So in this situation, that means that b is 100 and m equals 10. So we can write y equals 10x plus 100, and that's our equation. So this is definitely one of those situations where there's a lot of words, and at first that can seem intimidating, but hopefully now that we've walked through it, it's like, okay, that's not super bad. Let's do another one, and hopefully that will help as well. Example 6, you decide to make cookies for your math class. This is very hypothetical, theoretical, whatever, because as we discussed in actual class today, there's, peanut allergies and germs and things like that. So we make hypothetical cookies for our math class. If you make 24 cookies and decide to hand them out 2 at a time, write a linear equation to represent the situation. So what are you starting with? Well, you're starting with 24 cookies. How much are you changing over time? This one is a little bit different because we are not gaining 2 cookies every time we hand out 2 cookies. We're actually losing 2 cookies. So that would give us a negative slope. And our equation would be y equals negative 2x plus 24. Now, depending on your situation is how likely it is that you would, actually want an equation to work some of this out. In example 5, where we were talking about money and you might be trying to get to a fairly large amount of money, an equation might actually help you figure out some things. It's also helpful to be able to change out numbers so that if you realize you can save more per month, or if you realize that you can add in birthday money somewhere along the way, so you can add more kind of to your starting amount. Those are helpful things to be able to do with an equation. When you have something like this where you have 24 cookies that you're giving away 2 at a time, you probably don't need an algebraic equation for that. But if instead you were doing a bake sale and you had, 2,400 cookies and were trying to figure some things out about it, then that might be a situation where an equation would be helpful. If you haven't already figured this out as far as math work problems go, just because you can turn it into a math problem doesn't mean that it's actually a realistic situation. But also, it can be really difficult to come up with applicable real-life situations for the math you're doing without it being super complicated. So we've got to find this balance kind of between, okay, technically we would never do this, right? But if you can use your imagination, you might see where this could be helpful to someone else who's doing something on a much bigger scale. So, your turn. Can you think of some situations that you could model with a linear equation? If so, leave me a comment and tell me about it, and I will be excited to see, and I'll totally respond and maybe even make another video follow-up with your responses. So let me know of a situation that you think has a starting amount and then a constant change over time. Let me know in the comments, and it'll be a fun time. Thanks so much for watching. This was a nice short video, so now's the time for you to go to my website, get that practice page, and do some practice to make sure you really understand what's going on. And then I'll see you in the next lesson soon. Bye.